All right, let's take a minute and just review our two probability formulas. Okay, the first one is the probability of A or B. Remember, that's the probability of A plus the probability of B minus the probability of A and B. Now, if they are mutually exclusive, meaning that they don't intersect, then that probability is going to be 0. If they do intersect, then you'll either be given that probability, or remember, if they're independent, then the probability of A and B is the same as probability of A times the probability of B. So you can actually multiply those two together if you know that they're independent and do that subtraction if you're not given the probability of A and B. All right, so we're just going to quickly review combining random variables. We just did this, so hopefully this is fresh on your mind. The number of calories in a 1-ounce serving of a certain breakfast cereal is a random variable with a mean of 100 and a standard deviation of 10. The number of calories in a cup of whole milk is a random variable with a mean of 140 and a standard deviation of 12. For breakfast, you can eat 1 ounce of cereal, so I'm just going to underline that, with a half a cup of whole milk. Let T be the random variable that represents the total number of calories in this breakfast. Okay, so what is the mean of T? So remember what T is going to be. So T is going to be the total number of calories. So the total number of calories is going to come from 1 ounce of cereal. So 1 ounce of cereal plus a half a cup of milk. Okay, and we want the total number of calories. So let's just go back to what we know about cereal. So first of all, we know that cereal has a mean of 100 calories. So remember, when we're trying to find the mean of a random variable, I can just add the two means, okay? So the mean of the total amount of calories is going to be the calories in 1 ounce of cereal plus a half a cup of milk. So the number of calories in my cereal was 100, but I'm not using the total amount of milk of 140. I'm only using half of that. So I'm going to add 100 plus 1/2 of the calories of milk to get a total of 170. And that's your combined mean. Now, how do we find the standard deviation? So remember, when you find the standard deviation, you have to add the variances first. So I think of this first. So here's my ounce of cereal. I use the whole thing. So I'm going to think, okay, to get that variance, I need to square 10. Now, for my half a cup of milk, I need to find that new variance. Well, that new variance comes with my standard deviation of 12, so let's find that variance. But remember, I'm not doing that entire thing. I'm only doing half of that. So I need to square that also. So here's the variance of my cereal, and here's the variance of my milk. All right, and then in order to get the standard deviation, what you're going to do is add the two together and then take the square root. Remember, you never add standard deviations. You always add the variances and take the square root to find your new standard deviation. This is an example of a question from your quiz. I would just suggest that you take a minute and review this. And here's just a hint on how to start this question. If you have a question on how to do this, please let me know. So this question says, what is the probability that Angela finishes before Menehil? So the first thing you always want to do here is Angela finishes before Menehil. So that is going to be saying here the time of Angela is less than Menehil. So we're basically finding the probability that Angela minus Menehil is less than 0. So now for my random variable, in order to find the new mean, you're going to subtract the two means. So you're going to do the mean of Angela minus the mean of Menehil to get the standard deviation of Angela minus Menehil. Remember, you're going to add the variances. So you're going to add the variance of Angela plus the variance of Menehil and then take the square root of that in order to get your final answer. Okay? If you have questions on how to go through that, please let me know and I'll be happy to help. All right, so let's now review tables and probabilities. Let's take a look at this first example. A small ferry runs every half hour from one side of the large river to the other. The number of cars X, so that's our random variable, on a randomly chosen ferry trip has the probability distribution shown below. So remember that this is our random variable X, and this is going to be the probability of X. All right, what's the probability that a car has at least that the ferry has at least 3 cars on it. So at least 3 means 3 or more. So I'm going to add up this plus this plus this. What is the expected number of cars that are on the ferry? So what you're going to do to find the expected number of cars on the ferry, there are actually 2 things. You can plug this into list 2, okay? And then you're going to plug that into list 1 and list 2. Then you can go to stats, calculate 1 var stats, and then you just need to make sure that you're typing in L1, comma L2, and that will actually give you the mean and the standard deviation, which is perfect. However, just make sure that you're showing the work for the first 2 and the last one. All right, so remember to get the standard or the expected value here, we're going to multiply this together, add it to multiplying 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 this together, and add it to multiplying this together. So then in your work, you would maybe just want to show your first one, your second one, and your last one, and then your expected value for the number of cars on the ferry, and that would be 3.87. Okay, so, and that will also give you your standard deviation too, this 1 var stats. And then on your formula sheet, you can actually even just write out what the formula is as long as you have some sort of formula to show you. If a ferry ride costs $5, what is the mean and standard deviation for the cost of the trip? All right, so this is a transformation. This is not a combination. So we know that the mean is going to be 3.87. So we're just going to take 5 times that mean in order to get the new mean. Now the standard deviation I got from my graphing calculator by doing these calculations right here. So for the standard deviation, we're just doing a transformation. So we can just multiply 5 times the standard deviation in order to get the standard deviation for the cost. All right, so I'm just going to go through each of these examples here. Just to make sure you understand the difference between them all. All right, so a simple random sample, remember a simple random sample is whenever you can put everything in a hat and everybody has an equal chance of being selected. All right, a convenient sample is just a sample that is easy to gather. So this is a sample, let's say that you're sitting outside of Starbucks and you're just gathering samples that are outside of Starbucks, or let's say that you work at Target, so you're asking the people that come into Target. So a convenient sample is a sample that's easy to gather, and it does often have bias because the people that are at that situation, so if you're asking if people like coffee and you're asking them outside of a coffee shop, then most likely they're going to say yes, and that's not going to be a good representation of the population. Remember, a cluster sample is let's say we have like 9th graders, 10th graders, 11th graders, and 12th graders. A cluster sample is, in my hat, I'd put all the 9th graders, all the 10th graders, all the 11th graders, and all the 12th graders. I'd shake my hat up and I would pull maybe all the 9th and all the 12th graders, and the 10th and 11th graders would all get shut out. They would not be part of the sample. A stratified sample is when I have a bin of 9th graders, a bin of 10th graders, a bin of 11th graders, and a bin of 12th graders, and I take a few from each of this bins. So maybe I would take 2 9th graders, 2 10th graders, 2 11th graders, and 2 12th graders. Therefore, everybody in the different scenarios are going to be represented in my population. A systematic sample is maybe counting every 5th person that comes in, every 3rd person that comes in. It's a systematic, you have a system in place or every 4th name on the list. Something like that. So the 4 principles of experimental design, so this is just whenever we're creating an experiment, is replication. Now, replication does not mean we're doing this many times. It means that literally somebody else could take the experiment that you did and recreate it. Remember, you have to have random assignment. Without random assignment, we cannot establish cause and effect. Okay, so with random assignment, this allows us to establish cause and effect. Okay, we need to have a comparison at the end. So what are you comparing, and you need to make sure that you're putting it in real life scenario. Okay, so what are we comparing? We're comparing the height of the tulips. So the random selection happens before the experiment begins, and that allows us, in order to make inference to the larger population. Okay, so if we don't have random selection, then the only thing that we can do is make conclusions about the people in the study. So we want to make sure we look for that random assignment and random selection when we're establishing cause and effect and inference to the larger population. All right, so there are types of bias that can happen when we are doing sample surveys. The first is a non-response bias. So non-response bias means that you sent out surveys. So you sent out 500 surveys to FCPS students. So you sent out those surveys, but only 300 responded. It's it's non-response bias because you chose the people that are going to be part of the survey and they chose not to respond. Voluntary response bias would be having a sign, so maybe we have a giant sign outside of FCPS that asks the question and anyone can answer. And remember, people that have strong opinions are usually going to be the people that answer those questions, okay? A leading question is going to be something like, how strongly do you agree with the fact that we should all be going back to school? So a leading question is going to lead the person in one direction or the other. The person doing the interview can lead to bias, such as a police officer. If they ask you how many times you speed, you might lie because you don't want them to think you're speeding more often than you are. Undercoverage is whenever we miss a certain population or a certain portion of the population. So for example, this would be if I'm doing a survey and I call everybody with landlines. Well, we're going to miss every single person that does not have a landline, and they would not be part of that sample. All right, so there are 4 different types of experimental design that we've talked about. Remember, completely randomized design was when you start out with like 300 people, and then you would give them each treatment A and each treatment B. So you'd randomly assign treatment A and you'd randomly assign treatment B. Okay, so this is kind of like a simple random sample in that everybody starts at the beginning and then we're just paired off into groups, okay? But simple random sample, completely random design are completely different. So a matched pairs design, remember, would be one of 2 things. We have 300 people, and each of those 300 people on day 1 are going to do treatment 1, and then on day 2 they're going to do treatment 2. So for example, you would say, okay, every single person's going to flip a coin, and then if it's heads, they're going to do treatment 1 on day 1. If it's tails, they're going to do treatment 2 on day 1, and then on day 2 they will do whatever treatment they did not do on day 1. So one person does both treatments. Okay, the other thing with matched pairs is you can pair them up with people that are similar. So we'd have like A and A together, and then B and B together. They have to have similar characteristics, and then you'd flip a coin and one person would get treatment 1 and one person would get treatment 2, and then you compare the effects within that group. Okay, a block design is used whenever we have some sort of characteristic that is going to influence the results. So for example, let's just say that the age is going to influence if we're talking about doing a new running plan. So we think that age is going to have a difference. So what we would do is we'd block by age first. So we'd have age group 1, age group 2, age group 3, and then through each of those groups, they would get treatment 1 and treatment 2. So you block before it happens. Hopefully you looked at stratified design and you were like, Mrs. Price, what are you talking about? You're right. That is correct. Okay. So the stratified design, that does not, like, this is not even a design. We do not mix the words with sampling, with experimental design. Okay. So what do you need in order to establish cause and effect? So remember, that needs to be random assignment. And what do we need to make inference to the larger selection? That is going to be random selection. And that's what we already talked about.